Uh, Hi, welcome students. So in this video we will solve some MOSFET related problems. Let us consider MOSFETs with these specifications. So for NMOS transistor, so let us assume this is for NMOS FET. So let us assume that Kp is equal to 200 microampere per volt square and VT is this, and for PMOS let us assume the same parameters as so and so. Now for all the problems let us stick to these specifications. Now here we are asked to find the region of operation of the MOSFET for this circuit. So we know that there are three different regions of operation. One is cutoff and other is linear and saturation. Linear is also called as triode region. Suppose if I write this as the IV characteristics, which is the output characteristics. This is output characteristics of MOSFET, where for a given VGS, suppose if you change VDS, I'll get certain value of ID. So this is how it goes. So this is the characteristics, and on the x-axis you have VDS and y it is ID, and this is for a given value of VGS. So we know that we have a demarcation voltage which we call it as VDS sat, which is the saturation voltage, and it is given by VGS minus VTO, where VTO is the threshold voltage of the MOSFET. So this is VDS sat, which is also called as overdrive voltage, VOV, and if the value of VDS is greater than VDS sat, and of course with VGS greater than VTO, provided the gate to source voltage is more than VTO and VDS is more than VDS sat, I will say the MOSFET is in saturation. This is saturation region where the current is constant, So this is this region of operation. So this is saturation region, and we have one more region which is over here, where of course if you can see in the saturation region, as the value of VDS changes, there is no change in the value of ID. So in saturation region, ID is independent of VDS. So ID will not change with VDS. So that's why it is independent. Since it is independent of it, but ID depends on VGS and of course the dimensions so and so. So dimensions of the MOSFET, Kp and VTO. So ID saturation is given by the expression half Kp W by L VGS minus VTO whole square. So this is the expression for ID in saturation. Similarly, for voltages of VDS less than VDS sat, here you can see the current is depending on, the drain current is depending on VDS. We call it as linear region or triode region of operation. So the condition is VDS has to be less than VDS sat, and of course VGS has to be greater than VTO. Now ID is depending on VDS. The expression now is ID linear now given by, so half Kp W by L to VGS minus VTO into VDS minus VDS square. This is the expression for ID in linear region. It depends on VDS. So this is what is linear region. So we are having the MOSFET is said to be in sorry, let me just come down here. So this is for saturation. This is okay. With this basis, let us solve what is this problem is. So To solve that problem, let me consider, okay, let's take a sheet, okay, here. So what is asked now? So we have been asked to find the value of, or the region of operation. So let me rewrite all these things. I have this is 0.6, and I have been given VDD is equal to 1.8 volt. This is 1K. This is W by L is 40, and this is RD. Okay, with these specifications, let us find the region of operation. So we know that we have to find what is VDS, because VDS is the one, of course we have to compare VDS with VDS SAT. VDS SAT is given by VGS minus VTO. So what is VTO? VTO is equal to 0.4 volt, that is threshold voltage. We also call it as VTH, and VGS in this case is 0.6 volts. This is what is 0.6. So then what is VDS SAT? VDS SAT is given by 0.6 minus 0.4, which is 0.2 volt. So I need to find now what is VDS is. So if the found out value of VDS is greater than 0.2, then it is in saturation. If the value of VDS is less than 0.2, then it is in linear region. So then how do I find the expression for VDS? So VDS can be, of course I can rewrite this as a battery, something like this. So this is VDD. I can write a KVL for this. So I can write, okay, you can consider this is voltage rise, which is VDD, and there is a voltage, because I know that there is a current ID flowing through this. So there is a voltage drop here, it is minus ID into RD, and there is one more voltage drop, this is VDS. This is minus VDS equals 0. So from this KVL expression, written for this outer loop where VDD minus IDRD minus VDS is equal to 0, from this I can write VDS is equal to VDD minus ID into RD. So now I got the expression for VDS. Now I need to find the value of VDS. So to find the value of VDS, this is the equation, but I know VD, I know RD, but I don't know what is ID is. ID I need to find it. So what is the ID expression? ID is equal to, assuming the MOSFET is in saturation region, half Kp, let me write it as ID SAT, half Kp W by L VGS minus VTO whole square. Upon substituting this as half into 200 micro, W by L is 40, VGS is 0.6, VTO is 0.4 whole square. Upon substituting all these things, so what I'll get is, so it is 0.5 into 200 exponential minus 6 into 0.2 whole square. I got the value as, so how much is the value now? So ID is equal to, so this is 400 microampere. This is the current. So now this is the current that could flow in the MOSFET. So if this is the current, then what is VDS? Then VDS is equal to VDD minus ID into RD, which is nothing but now 1.8 minus 0.4 milliampere multiplied by how much is resistance? It is 1 kilo ohm. So it is now 1.8 minus of 0.4 milli. Of course you can just take out this milli and K will go off. 0.4 into 1, so it is 0.4. So what is this? So it is 1.4 volt. So this is VDS. What is VDS at? So from this VDS at is 0.2. What is VDS at? It is 0.2. So now you have to compare VDS and VDS at. Is VDS greater than VDS SAT? That is 1.4 is greater than 0.2. So MOSFET is in saturation. So it's in saturation region. MOSFET is in saturation region because VDS is more than VDS hat. Okay, likewise we will do for one more. So let us consider this. Again we are supposed to find out the region of operation. Again you need to find out what is VDS and find out what is VDS sat. Compare them. What is VDS sat? VDS sat is given by VGS minus VTO. But what is VGS? If you can see, VGS is voltage between gate and source. So what is the voltage at gate? Voltage at gate is 1.8. What is voltage at source? So this is 0. So VGS is now written as, VGS can be written as VG minus VS. VG minus VS. So that's what is 1.8 and this is 0.4. It's actually 1.4. This is VDS sat. Now this is VDS sat. Let us find out what is VD. So again you can write the KVL for this. Shall we write VDD minus ID into RD minus VDS is equal to 0 by writing the KVL for this. So from this I can write VDS, the voltage across the drain and source is nothing but VDD minus this drop. VDD minus ID into RD. But what is ID? If the MOSFET is in saturation, ID is given by, ID saturation is given by half Kp W by L VGS minus VTO whole square. So let me substitute those values and then find out. So it's actually now 0.5 into 200 micro into 10, that is W by L is given 10 and VGS is 1.8 minus 0.4 whole square. So let me find out how much is ID. It is now 100 exponential minus 6 into 10 into 1.4 whole square. It is now okay 1 point. So now the current is how much? 1.96 milliamperes. It's 1.96 milliamperes. Since the current flowing through this is 1.96 milliampere, suppose if a current of now suppose if you substitute it here, so then what is VDS? VDS is equal to 1.8, that is VDD minus 1.96 milliampere multiplied by RD is equal to 10K. So this K and milli will go off. So it is now in with 1.8 into 19.6, which comes out to be negative. So it is 1.8 minus 19.6, which is minus 17.8 volt. This is VDS if the MOSFET is in saturation region. So you cannot have VDS negative to keep the MOSFET in saturation. So naturally, since VDS is not greater than 1.4 volts, so I have to decide MOSFET is in linear region. Why it is in linear region? Because VDS is certainly less than VDS sat. So can we actually find out what is the current that is flowing through this? Since it is not in saturation region, it has to be in linear region. If it is in linear region, can I find what is the current that is flowing there? So I can certainly find out what is the current that is flowing in the MOSFET. Okay, how do I find that current? So let me just find it here. So how much is this? This is the ID expression now. So what is ID is equal to, in linear region, it is half Kp W by L 2 VGS minus VTO into VDS minus VDS square. So you can write it as, suppose if you are asked to find what is, this is an extra thing, otherwise you can say that okay, MOSFET is in linear region. So this is straightforward, the problem ends here. Just to ensure that try to know what is the current that is flowing in the MOSFET. So we are just trying to proceed. So it is now half Kp W by L 2 into what is VGS? It is 1.8 minus 0.4. But what is VDS? It's again now 1.8 minus ID into 10K minus of 1.8 minus ID into 10K whole square, close the bracket. Now you have to find the value of ID. So you can find the value of ID now here. What do? Alpha A, alpha equals, it is 100 exponential minus 6 into 10 into 2 into 1.4 into, sorry, let me just make it 1.4 into 1.8 minus alpha A into 10 exponential 3, close the parenthesis, minus of 1.8 minus alpha A into 10 exponential 3, close the parenthesis, square, close the parenthesis, shift cal. Let me find out what is the current. I just fed this equation. Okay, now the current is, okay, one of the current is 96.69 milliamperes, which cannot be an answer. Let me find out the other possible answer. Equals 1 exponential minus 9 equals shift cal. I'm trying to find the other root of this. Other possible current is, I'm just waiting. I'm looking for the answer. Oh, this is again coming out to be that. Okay, let me just find it. Equals 1 exponential minus 12 shift cal. What the answer? Let us see. There is some issue with that. Let me just find out whether I fed the equations properly. Now this is 100 exponential minus 6 into 10. Okay, this is one parenthesis. This is second one. Close parenthesis, next it is 1.8. Let me close one more. Shift cal. Let me just go back and see. Okay, you can see the mistake that I have made here. So while entering the values, I think I have made a mistake here. You can see this is the value. Of course, this is what happens. See now, okay, we're substituting this value. So I need to substitute it as, so let me just give you that. So this is the equation I have. You can see now it is, this is alpha A, this is half into 200, then it is 10, 2 into 1.4, then it is 1.8. This would have been minus, so I just make it divide by, so that's the error, that's the mistake. I have to make it minus, then do shift cal. Okay, that last parenthesis, I think. Okay, let me just take out this. What is that? I have to take out this. Shift cal. I should get, this is the answer now. Okay, what is the current? So current is 173.65 microampere. This is one of the current. Let me find out. Okay, this may not be the answer because there it was with, if you want to find the other root, equals 1 equals shift cal. Let me find out the other current. Other current is, okay, it comes out to be the same. So it is 173.65 microampere is the current that is flowing. if this current is flowing, is it consistent? So is this circuit consistent? You can find out that. So if this is ID, then what is VDS? VDS is equal to VDD minus ID into RD. So it is this current into 10 exponential 3 is the drop. Okay, equals. So what you have is, okay, it is now 1.8 minus 173.65 micro into 10K. So what is VDS now? VDS is now 1.8 minus, minus 173.6 exponential minus 6 into 10 exponential 3. So it is now 0.064 volt. Since VDS is, what is VDS at? VDS at is 1.4 volts. So since VDS at is 1.4 volt, VDS is 0.064 volt. Now MOSFET is in linear region. So here only we declared that okay, MOSFET is in linear region, but VDS was coming out as negative, which is not a correct value. So we actually found what is the actual current that may flow in the MOSFET. So, and that current flowing is 173 microampere, which is in the linear region of the MOSFET. So it's somewhere here. So it is somewhere. So likewise, of course, this what happens if you don't properly edit the values. So while entering, I made a mistake of 1.8 divided by so and so. So that's why you are getting a wrong answer. So you may have to just find out, okay, why it is going wrong. Okay, fine. Let us see this. So it takes understanding of every concept. Now let us find out what is the region of operation of this MOSFET. So again, can I write what is VDS now? So VDD minus ID into RD minus VDS is equal to 0 is the expression. So can I now write VDS is equal to VDD minus ID RD? So again, I know what is VDD, I know what is RD, but I don't know what is ID. So to get the expression for ID, if the MOSFET is in saturation, it is given by half Kp W by L VGS minus VTO whole square. What is VGS now? VGS is nothing but voltage at gate minus voltage at source. See, there is a gate connected to drain through this resistor. So this resistor actually doesn't have any significance now, because what is the current that is flowing here? Actually the DC current flowing here is 0, because this is a dielectric medium. The current cannot go here. This current is 0, means no current flows. So drop across this RG is 0. So whatever is the voltage at drain, same is the voltage at gate. So I can write it as VD minus VS. But what is VD? The voltage at drain is nothing but VDD minus, it is VDD minus ID into RD is your VD minus VS. So what is VS? VS is 0. It is 0. So VGS is VDD minus ID into RD. So I can come back here and then substitute it as half Kp W by L. What is VGS? It is VDD minus ID into RD is VGS minus VTO whole square. So this is my ID. So I can find out what is, because now I know all the values. So I can find out, it is now alpha A, okay, alpha equals, it is this 0.5 into 200 is 100 exponential minus 6, W by L is 40 into 1.8 minus alpha A into RD is 1 exponential 3 minus 0.4, close the parenthesis, whole square, shift cal. I will get the value of, so this is the value of, one of the value of ID is, okay, now it is 920.3 microampere. Let us find the other value. To find the other value, simply say equals some larger number equals shift cal. Okay, other current is 2.12 milliampere. 2 milliampere. So this cannot be a current because you have a 1k resistance. If this much current flows, then you cannot have 2.12 volt as the drop because the applied voltage itself is 1.8. So this is not a ID. This is not ID. So let us take this as ID. So then what is the expression? Then what is your VDS? So VDS is now given by VDD minus ID RD. So how much is this now? So it is now this much. Oh, it's 1.8 minus of how much is ID? It is 920.3 exponential minus 6 into RD is 1 exponential 3. So this is now 0.8797 volts. This is VDS. But what is VGS? Okay, what is VGS now? VGS, because VGS need to be found to find what is VDS sat. So what is VGS? So if you can see here, is this VGS is equal to VDS? VDS is equal to 0.8797. Then what is VDS sat? VDS sat, because usually we know that when gate and drain are shorted, MOSFET is always in saturation. Is it not VGS minus VTO? Is it not 0.4797 volts? See now, VDS is this, VDS sat is this. So is VDS greater than VDS sat? Because this is VDS, this is VDS sat. So 0.8797 is more than 0.4797. So MOSFET is in saturation region. MOSFET is in saturation. Basically, we are supposed to find what is value of VDS, compare it with VDS sat. If VDS is more than VDS sat, then MOSFET is in saturation region, otherwise it is in linear region. So in the next video we shall see, okay, let us finish off this also. This is one more, again if you write the KVL for this, is VDD minus ID into, okay, let us write it as RD, this as RS. Before we write the value of, I can use a different pen. This is RD plus VDS plus ID into RS minus, okay, let me call it as VSS, this is VDD minus VSS equals 0. So from this I can write VDS is equal to, oh sorry, this is actually minus, this is minus, this is also minus, okay, this is actually plus minus, plus minus, plus minus, and this is plus VSS, correct? We actually had it like this. So we are actually going like this. This is voltage rise, this is voltage rise, so and so. So then what is VDS now? VDS is equal to, okay, now this is VDD plus VSS minus ID into RD plus RS, correct? Now it is 1.8 minus ID into RD plus RS is 1.5 kilo. It's 1.5 kilo ohm. So this is VDS, but I don't know the value of ID. I don't know the value of ID. So what is ID given by? It is half Kp W by L VGS minus VTO whole square. Now what is VGS? VGS is VG minus VS. If you can see, gate is grounded, whereas source is this potential. It's actually ID into RS minus of VSS, correct? So now this is ID into RS is 500 ohm, it is minus 0.9. So I can substitute that back here. So what is ID is equal to half Kp W by L. VGS is 0 minus of ID into 500 minus of 0.9 minus of 0.4 whole square. I need to look for ID value. This is fine. Half Kp W by L. In that VGS I have this as VG is 0 minus ID into 500 minus 0.4 minus of 0.4 whole square. So let me find out for ID. So it is now alpha, let me just do it here. Alpha equals 100 exponential minus 6 into how much is W by L? It is 40. You can see W by L is 40 here. So this is W by L 40 into 0 minus, open the parenthesis, alpha A into 500 minus 0.9 minus 0.4 close square, shift cal. This is one of the current, which is 2.61 milliampere. This is not a possible answer. Let us find the other one. Equals 1 exponential minus 6 equals shift cal. Other possible answer is 381.96 microampere. This is a possible answer. So let us find out what is VDS now is. So I have this expression to find the value of VDS. So VDS is now equal to 1.8 minus ID into 1.5 kilo ohm. If it is 1.5k, so it is 1.5k into, let me make it 1.8 minus ID is 381.96 exponential minus 6 into 1.5 exponential 3. Can you see the voltage is 1.227 volt is VDS. How much is VDS SAT? VDS SAT is VGS minus VTH. But what is VGS? VGS is this. VGS is 0 minus of ID 500 minus 0.9. So let me find out what is this. So is it not 0 minus of 381.96 exponential minus 6 into 500 minus 0.9 close the parenthesis? Is it not 0.709 volt? So what is VDS SAT then? VDS SAT is equal to 0.309 volt. So this is VDS SAT. That's what is this. But what is VDS? VDS is this. This is VDS SAT. So if you can see this, VDS is more than VDS SAT. So MOSFET is in saturation. So this is answer is MOSFET is in saturation because VDS, which is 1.227 volt, is greater than VDS SAT, which is 0.309 volt. So this way we can able to prove that in this MOSFET, in this circuit, MOSFET is in saturation region. Thank you.